Welcome, my name is Blake Shalacy, and I'm going to be teaching you about Hooke's Law. Now, we start out with the basic equation F equals Kx. F is equal to the force of the push or pull on the spring. And K represents the spring constant. This is the stiffness of the spring, and it gives the spring its elasticity. And finally x, which is how far the spring has been pushed or pulled from its natural length. And this gives us the F equals Kx fundamental equation for Hooke's Law. Today we'll be finding work, which will incorporate a new function, but is still derived from the original F equals Kx function. The new formula that we will be using today is W equals the integral from a to b kx dx, where W is work, k is the spring constant, and x is the distance that it is stretched. Now the boundaries a and b are determined by how much the spring is stretched, and due to this formula you can have any starting point. It does not have to be the natural length of the spring. Now let's do a problem to see how this works. 18 foot-pounds is needed to stretch a spring 4 inches past its natural length. How much work is needed to stretch the spring from 4 inches to 7 inches? Now the first problem that we face is that we don't know what K is, so that is a priority, is figuring out what the value of K equals. We start with the new formula that we just learned, W equals the integral from a to b kx dx. We already know that 18 foot-pounds is required to stretch the spring from 0 to 4 inches. So we can plug in 18 for W and 0 for A and 4 for B, since those are the inches that it is stretched. When solving for the integral in respect to x, it comes out to be 1/2 kx squared. You then plug in your boundaries 4 and 0. Since we have 0, it is irrelevant and you don't even have to worry about it. So it comes out to be 18 equals 1/2 k4 squared. Now we are ready to solve for k. We can square the 4 to equal 16 and then halve it, so then you have 18 equals 8k. Since we have 18 equals 8k, the next step is to divide by the 8, so we have k equals 18 over 8, but we're not done yet. To make it a little easier on ourselves and to be correct, we needed to simplify it a little more to make it k equals 9/4. Now we know the spring constant, which is k equals 9/4, which is extremely vital in solving the last part of this problem to find W, which is work. We're going to be using the same equation as before, so we can go ahead and plug in what we know. So we have W equals the boundaries from 4 to 7 as 9/4 x dx. The 7 and 4 represent the boundaries, which are the inches that it is stretched from 4 inches to 7 inches, and the 9/4 is the k value, and we are going to be solving for work. Now we know that the integral in respect to x in this equation is W equals 1/2 kx squared. When we plug in what we know, it comes out to be W equals 9/8 x squared from 4 to 7. It becomes 9/8 because it's 1/2 times 9 over 4. Then we must plug in the boundaries with top minus bottom, so it comes out to be 9 over 8 times 49 minus 9 over 8 times 16. The reason that the x comes out to be 49 and 16 is that it is still squared, and we are plugging in 7 squared, which is 49, and 4 squared, which is 16. 9 over 8 times 49 comes out to be 55.125. and 9 over 8 times 16 comes out to be 18. When you subtract 18 from 55.125, it comes out to be 37.125. This value becomes our final answer. The work required to stretch this spring from 4 to 7 inches is equal to 37.125 foot-pounds.